And here we're looking at a couple of practical examples of how the growth and decay model is implemented and how we can use our calculator to help us solve some of these questions. Alright, so here we have our first of two examples. A 50 milligram piece of radioactive substance is decaying at 0.3% per year. Now really, that's all the information you should need in order to write an equation to describe what happens to the mass over time. And you should know the equation will produce a graph something like that. However, they've been nice and given to you, where mass is equal to 50, which is the initial substance, multiplied by the percentage factor that reduces it by a set amount each year. So, recalling from last lesson, here, where we use this model, and A is between 0 and 1, it decays, using this equation to get our decay factor. Alright, so, determine the mass, the remaining mass after 20 years. Well, we know that the mass is equal to 50 times 0.997 to the power of n, where n is the number of years. So here we grab our calculator and substitute in 20, where the mass is 50 times 0.997 to the power of 20 is 47.08 milligrams. Remember units in your answer, and remember to answer the question. So this determines the mass remaining. We've given the mass remaining. If it asked for the mass lost, you'd have to do 50 subtract that answer to get it. Use a calculator or spreadsheet to estimate the number of years it would take to reduce the mass by half. So really it's asking, well, when is m equal to 25? One way we could do it very simply is to write the equation 25 equals 50 times 0.997 to the n question mark, and use solve to solve that. Comma n solve. That would be one way to do it. Not a very satisfying way. I think a graphical way is a much nicer way to show what's happening. So here's a graph I've prepared earlier. That is the graph of radioactive decay, and we can see that it goes from 50 down to well below 25, getting very, very close to 0 but never disappearing. It asymptotes towards 0. So somewhere around here is the halfway point. To find that, we can press tab and ask it to plot a horizontal line where y is equal to 25. That line, y is equal to 25, is halfway down the graph. Then we can go Menu, Analyze Graph, Intersect, and we can go above and below. We can see that after 231 years is exactly where these two graphs intersect, where the mass crosses the 25 line. So our answer here would be 25 years. Whoops, sorry, not 25 years. Let's go back in the graph. On this axis here is years, so that's 231 years. Alright, second example. The value of a house is purchased for $600,000 and is expected to grow by 12% a year. Let V by be the value of house after t years. So we can start with the rule V equals AK to the t. AK to the power of t, where A is the initial value and K is the multiplier. So V equals A, which is 600,000, times K, which is our multiplier, in this case 1 plus 12 and 100 to the power of t. And that would be our rule there. If you want, you can simplify what's in this bracket to 1.12. All right. Use your rule to find the expected value of the house after 2 years. Well, that's easy. Value equals 600,000 times 1.12 to the power of 2. And the next one here, value equals 600,000 times 1.12 to the power of 10. I'll let you put them in your calculators to answer. Use trial and error to estimate when the house will be worth 1 million. Well, trial and error is a really unsatisfying way to do something, especially when we know our house is growing like that and starting off at 600,000. And at some point it's going to cross the million mark. So we're looking for a very similar solution method as we did before, but this time with a different graph. Once again, there is value of the house. over 16 years, rising steadily, and at some point it will cross 1 million. So let's plot the line y equals 1 million by tab. Oh, it's not enjoying that, is it? 1, 2, 3, 1, 2, 3. Enter. Menu, 6, 4, left of it, right of it. And we can see that it reaches 1 million. 1 e to the plus 6 is the value for 1 million in scientific notation after 4.51 years. So, 4.51 years. If it asked for the number of months, we would write, well, whatever 4 years and 4.51 years is in months. Either way, that is all for now. But this time we have weekly homework. This will cover the entire week's set of videos. It's an indices test. I wouldn't do it currently. You need to watch the next video before getting the last bit of information you need. But that is a practice test on quizzes. It's not scored for time. It's not ranked. I'd like to see you all have a proper go at it. Don't guess your way through it. It'll be due by Thursday this week. Thank you very much.